I think we are missing some people. I will present.
Are you sure now?
Yes. Maybe I'll go to the My Open Math and do that. All right, can you guys see the screen okay?
Besides Bruce's head, yes. Here, this one you just chop it off like that. No, not that, Bruce. I want to see your face.
Okay, so the amount of time that Jake studied is Z. Julie studied half as long.
She's gonna fail.
So how can I write how long she studied in terms of Z?
It should be like Z divided by 2.
Yeah, that's it. Does that make sense? Z divided by 2 is half as long as Z, right? That's all that you have to do there. Mr. Smith and Mr. Stein drove together, taking turns. All together, they drove 290 miles. If Mr. Smith drove the first Y of that 290, how much of the 290 was left for Mr. Stein to drive?
290 minus Y.
Does that make sense?
Yeah.
Good, good. Now take the total minus how much the first guy drove, and then that should be how much the second guy drove. Hopefully those aren't too bad. If I bought our movie posters and they each cost $2, how much did I spend on posters altogether?
R times 2. Or no?
Yeah,
Yeah.
yeah, that's right. Is this okay for all you guys, not just Tyler? Good. Can you see, Abby? Oh, we are in solving equations 1. I'm just starting to go through these. I was just reminding everybody that if you go to the YouTube recording playlist, I've got videos that go over all the homeworks. So to help you study, you can go over those videos. I think I still have one more to post from yesterday, and I'll post this one from today. So you should have plenty of video review. And I also posted these 4 PDF versions. I'm going to repost those, though, with answers on them so that you could use those instead of the videos, if that's what you want to do. But right now I'm just going through question 4 on solving equations 1. We'll try to go quickly so that we can get to some of the other ones. Okay, 4 more, a number that's 4 more than the product of the volume V and 9. Anybody else want to try that one? You have the product of V and 9, and you want 4 more than that.
Take 9 times 4.
What's that?
Take 9 times 4.
Not 9 times 4.
And 9 times V.
9 times V, and you want to be 4 more than that.
So you take 9V times 4?
No. 9V
Plus.
plus 4, yeah. Does that make sense?
Yeah.
Who's making the noise? Who is that? Okay, X is a quantity. Carol and Catherine sweep the sidewalk. X represents the portion swept by Catherine or Carol. So you just pick one of their names. We'll say Catherine. I don't know why they do that. So Catherine did X. That's the proportion that she swept. Let's see. Okay, write an expression representing the proportion of the walk the other person swept. Remember that the variable X goes with Catherine here, and that there's one sidewalk to sweep. So that's a very weirdly odd worded one. I guess these are fractions. So
What Jeff, I think you have to do like whatever your amount is minus X.
yeah, that's usually what it was. So one minus X. They said there's one sidewalk. That's what's kind of weird about it. So these are decimals. Yeah, that works.
Yeah.
So these represent like a percentage as a decimal. So like 0.5 would be 50%. That was kind of trickier than they usually are.
Yes, and mine was just like a split line.
Yeah, usually it was like a number like 100 but this was like 1 for 100%. Okay, 9 more than a number. Your number is X. Anybody got that? How would I write a number that's 9 more than X?
Do 9 plus X.
Yeah. So hopefully these ones aren't too bad for you.
Are you so smart, Mini Cody?
Mini Cody.
What?
Says Mini Cody.
Uh,
I missed it.
let's
Get a
try.
whole goatee now.
Yeah, actually.
Yeah.
Okay, here's an expression right there.
See, so what is cool.
I see.
And we want to pick which one of these matches that expression. So how would you say that?
There's B. Oh wait, you skipped some.
Yeah, I did.
Is it the third one?
Third one?
Or the
No.
second one? The first one.
What did you be?
Pick one.
9 plus 8.
It's the first one, right?
Yes.
Good. All right, this one, I'll try to zoom out. So
Oh,
you
you
can,
should skip this one. This one's kind of obvious.
well, I just want to make sure everybody's good with it. What would be the result of subtraction?
What?
What's the result of?
Let me look it up. That's a different. What's it called? EasyPlus.com?
What was that, Ethan?
Yeah, it's different.
Yeah, good.
What's the name of the
What are these symbols?
multiplication symbols?
Good. What is the result of a multiplication?
Right.
Good. A mathematical sentence that includes an equal sign. Yes. An expression doesn't have the equal sign. A result of addition. Very good. Result of division. Good. What are these symbols for? Very good.
91%
These easy for you?
I've never heard of that before.
All right, variables and or numbers combined with arithmetic operations.
Like, under 200?
Algebraic expression.
Yeah.
I'd give off a go, honestly.
Yeah, each side of an equation is an expression. Letters that stand for numbers.
That does,
Variable.
Yeah.
See what the goat thing? Usually, unless you look at these.
Okay, then the last one is obviously the process of elimination. this thing. Very good. The next question pretty much was all the same stuff. It only had coefficient, which was different. So which one of these was coefficient?
Here, let me look at one of the triple white ones.
One of these,
Seven.
no.
What are we looking at?
We want to know, this question is almost the exact same as the last, but this one has the word coefficient. So which one of these goes with the coefficient?
It's I,
It's not I.
then it's G,
No.
then it's H.
No.
It's one of them. I don't know. I'm stupid.
Oh, did you say H?
Mhm.
Yeah, that's H.
Ah, she's smart.
Yeah, so coefficient. So like when you look at this equation, 3 is a coefficient. It's a number multiplying the variable. Can you guys do 15? This one?
-15.
Yeah, good. So the opposite of C is 15, so C must be the opposite of 15. Okay.
So pretty much all those are the same.
Yeah, they're pretty similar. Here's 18 is a little different. Let me write that one so that oops. You guys can
Look at these.
all right, what am I going to do for this to solve this equation?
You do subtract 4 to -44, so -48. And then take -48 divided by -6.
Good.
Then C will equal that. I don't have that in my head.
No, that should be 8. It's 8. Good. Very good. But that's what do they call it? A two-step problem?
Yeah.
Because you first had to add or subtract, then you divided. Here's another two-stepper. Let me try. Hi.
How's it going, Mike?
Good. How are you?
Pretty solid. How's your vacation?
Pretty good. We're just going over some review before the test, so
Good test.
yeah. I'm looking at number 20 on solving equations 1.
Is this on my open math?
Yeah, I'm doing it on my open math. Just
Is there a review on that?
yeah, let me show you what I've got. I've already gone through this once, but I'll do it real quick for you. I did post the homeworks, solving equations 1, solving equations 2, linear relationships 1, linear relationships 2. So,
Yeah.
I think don't they just circle those?
I'm going to post these again because these ones I just posted the questions. I didn't post the answers. So I'll post them together with the answers so that you can review that in PDF form. Also, there was in the, if you go to the YouTube recording playlist, I go through all these homeworks in video. And the review that I've been doing for the last couple days, I'm also putting up there. So I'll post today's recording, and I did one yesterday that I haven't posted yet. So there'll be 2 more coming up, and you can use those to help you study. Your test will be in 2 parts. The first part will be next class over solving equations, and then the stuff. What's that?
What you said? What was it over?
The solving equations part.
All Alright.
So that's what we're reviewing today. After that, we'll probably do like another review and then another half of the test where you go over plotting lines and stuff like that.
Yeah.
Alright.
And I was going to do this one. This is, I guess, a 3-step. All right, so there it is. I'm going to have to combine like terms, isolate the variable to solve for it. How should I start?
I'll do plus 3x.
Okay, good.
Okay. And then minus 8.
Minus 8.
So negative 6. And then divide by 6. So it'll be negative 1.
Yeah. Good. So hopefully these are okay for you. These are the easier equations to solve. Let's try some with these fractions. So I've got 21 and 22 here.
That's a really like they're like.
So 21, I have z over negative 2 plus 3 equals negative 4. What should I do with these?
Minus 3, so it'll be negative 9 or 7.
Good. So z over negative 2 is negative 7.
And then we want to multiply negative 7 by negative 2.
Good.
So it'll be 14.
And then,
Yeah, the 2 negatives make a positive.
yeah.
Good. 14. How about the next one was, any questions on that one?
It's 7
22.
and
So here you have a whole thing over a number. So that's going to be a little different.
Don't you somewhere you like multiply those by 3 or something?
Yeah, so in this one, when it was just divided by negative 2, we could work with the 3 first and then worry about the negative 2. This one, because of the way the order of operations goes,
So wouldn't it be like 3x plus
yeah.
18?
oh, I'm going to multiply by 3 on both sides here. That will cancel there. And then it's 33 equals x plus 6. Does that make sense?
Oh, gotcha. Okay. Yeah.
It's kind of like this is like
Yeah.
that.
And then you just do minus 6.
Yeah, good.
With the Republic.
So x should be 27.
Yeah, I know, I
Yeah.
saw those.
All right, let's put those in, 14 and 27. Oops. Good. All right, let's try 25. Now, just as before, when I had something like x plus 1 equals minus 5, I would subtract this thing, right? Well, likewise, just because this is a fraction, it's a number like any other number. So if I have 1/15th, I can just subtract 1/15th, move it. That works. But now I have to write minus 1/15th over here.
Is it here? So,
So x is equal to minus
I would
5/12
know, it's like this size 7.
minus 1/15th.
It's like a one regular foot size. It's like-
All right, what do I have to do when I'm adding or subtracting fractions? If I was gonna add a half and a third,
Oh, you have to get the bottom in terms of like. correct?
yeah, I gotta find the common denominator. So in this case, the 2 doesn't have a 3, so I need to give it a 3. And I don't want to change the fraction, so I'm going to do the same to the top and the bottom. I need you guys to stop talking, please.
So it's 3 over 6.
Yeah, that'd be 3 over 6.
And then 2 over 6.
And then 2,
What did it say?
This one person.
I put this in here. Why did you tell me to come earlier?
yeah, so I give what the other side has that this side's missing. I do the same to the top as the bottom, because when you do that, you're really just multiplying this number by 1. And anytime you multiply a number by 1, you're not changing the number. I'm just changing the way it's written so that they can have a common denominator. And then once they have the common denominator, you can combine the tops, right? The 5/6. So this one, I'm going to rewrite this as, I'm going to think of 12 as 4 times 3. And I'm going to think of 15 as 5 times 3. Is that okay what I just did? You guys okay with that? Okay, so this thing over here is missing a 5 in the bottom, while this one over here is missing a 4 in the bottom. So I'm going to give a 5 down here, but I have to do the same to the top. And this, I'm going to give a 4 down here, but I have to do the same to the top. So that makes it negative 25, and then minus 4, all over, this makes 60 down here. So that's negative 29/60. I don't think that reduces. I think 29 is prime, so I think that's the answer.
Wait, are you on 24?
23.
Oh, you're on the same one still? I don't think it makes you reduce it.
Yeah, I don't think you can. 29 is prime.
Oh, yes, it's reduced.
Yeah, good. What's the trick to 24?
Well, don't you want to get rid of K? Or no?
I'll do this one too.
I'm not saying. Once.
Okay, in this problem,
Yeah.
you have a fractional value multiplying n. If I just had a number multiplying n, I would divide by it. But I can do that with this. It looks confusing that way, but that's okay. You can do this way. And then when you divide by a fraction, it's equivalent to multiplying by the reciprocal. So what you can really just do is,
5 over 3 times 9 over 2.
yeah, you can really just multiply by the reciprocal to cancel. But you have to do the same to both sides as always in algebra. So, yeah, there you go. So n would be negative 45 over 6. That can reduce. 3 goes into that. So that's negative 15 over 2, I think. Good. Same thing, dividing by a fraction is the same thing as multiplying by the reciprocal. So that should be negative 8/6, which reduces to 4/3. No, I did that wrong. A is, if I multiply by 8 and 1, that should be right. Oh, no, I just multiply by 1/8. My bad. So it should be 1/6, and then you're gonna multiply by, how do I do a multiply?
I just do the asterisk button star.
Let's see if I can. Yeah, and then it'll be 1/8. And when you multiply those, yeah, you'll get negative 48 on the bottom. This one, let's do that one. That's a pretty weird one. So this one is similar as when the variable was on top, but it's a little different because now the variable's on bottom. I'm going to add the 4. So I have 5 over y is 7. And now there's a couple ways I could think of this. I'll do it sort of 2 ways. One way you can think about this is think of 7 as being 7 over 1. And then it's legal to flip both sides of an equation simultaneously. So,
Y over 5, 1/7.
yeah, so then I can multiply by 5, and y should be 5/7. Alternatively, I could have just multiplied both sides by y, and then 7y is equal to 5, and then divide by 7. Either way, I get 5/7. So it's up to you how you like to write that. We'll do this one as well. It's kind of weird. Give you guys a new color. A is 1/4 of 5y plus z. They want us to solve for y. So first thing, we'll distribute into the parentheses. To solve for y, I've got 2 other variables here, but to solve for y just means getting it by itself on its own side of the equation. So I can just move this term over by subtracting it. And then I will multiply by the reciprocal to get this off of this side. But I have to do the same over here. So y is this, 4/5 of a minus z over 4. If I distributed that, which I can, I would get 4a over 5 minus z over 5, which is alternatively 4a minus z over 5. We'll just treat them like they're numbers. All right, that's most of the unique types of questions on that one. Let's look at the last questions on solving equations 2. Starting at 14. So this one is like the ones we were doing before, same with 15 and 16. It just wants you to distribute first when you have the parentheses. Then you're going to combine like terms, isolate the variable. Really a lot like what we're doing. Yeah, good. I want to find the two variable, two equations questions so that you can practice that. This question, number 4, you're given some points. There's the x-intercepts where the lines cross the x-axis. Those are at B and D. You have the y-intercepts, which are A and E. And then you have the intersection of the two lines, which is at C. Which of these points represents the solution to the system of equations? When we talk about solving a system, which of these points do we find? This is linear relationships 2. Number 4.
I just don't have it.
It might have been, it looked like it was hidden for some reason. I'll turn it on after this.
What is BC?
Yes. Yeah, when we solve the equation, we find the intersection. So that'd just be C. Yeah. This one, you guys can solve this. If y is equal to this and y is equal to this, the right-hand sides need to equal each other. So I could just set this right-hand side equal to that right-hand side because they must be equal to each other. And I could solve for x and then plug back into either one of them, solve for y. You can also just plug these numbers in for x and y in both of them and make sure that it works in both of them. So you can just sort of plug these in and test them out. It works that way too. Let's try solving this. What did I just do? Like this one maybe. So we have 3 different ways, all get you the same answer, to solve a system of 2 equations. There's substitution, there's elimination, and there's Cramer's rule. I'm going to use, I guess, elimination. I'm going to try to eliminate the x's. I'll eliminate the y's, actually, because I'd like to work with smaller numbers. So I'm going to rewrite this first equation by multiplying every number by 3. That way the y is 3 here and the y is 3 here. So I'm going to make minus 3x plus 3y equals 6. That's fair for me to do. And now if I add the left-hand sides and add the right-hand sides, you will get x is minus 3. I will then plug that in to the original. So that turns into 3 plus y equals 2. The y is minus 1. So you could write that as a point. That was one method. You could also use Kramer's rule for that, where you make the matrices. And you could also use substitution. I'll do a substitution example of the same thing. I'll rewrite that.
One day I just saw
All right, for substitution, I'm going to rewrite. Quiet, please. I'm going to rewrite this first equation and so that I isolate y. I'm going to add x to both sides. So y is equal to 2 plus x. And then I can rewrite this equation. But instead of y, I'm going to put in that, 2 plus x. Then I can solve for x. This makes x, add 6 to both sides, and I get minus 3. So I get x is minus 3 again. I can plug that into here. I get minus 1 for y. So again, I get the minus 3, minus 1. So that's the substitution method. Lastly, you have Kramer's rule. So you get the same answer. Actually, I'm going to write these in different colors. I will do blue. I will do red, or I'll do green. And I will do red. I'm going to make 3 matrices. One is as the x and the y values. One has the, I'll make the other ones. This will have the green values. But the X matrix will replace the X column with these extras, while the Y matrix will replace the Y values with these extras. And we just need these determinants. I don't know. Determinant of D is these multiplied minus these multiplied, so 3 minus 4. Determinant of this matrix is negative 6 plus 9. Plus 3 then. And the determinant of this one is 9 minus 8. So y, or x, I should do, well, y is this dy over d. Minus 1. X is the dx over d. Just 3 over minus 1, which is minus 3. So once again, minus 3 minus 1. 3 ways to do the same thing.
Unnecessarily long.
Yeah. Quiet, please. It seems kind of unnecessarily long for the 2 by 2 system, but when you have 3 variables and 3 equations, I think it's kind of quicker.
Well, yeah, I was shocked.
So, you drained my battery.
So let's try just determinants.
Can I have my AirPods? Are they personal?
Yeah.
Those AirPods. Well, I can get it.
Oh, yeah.
Things are 34. Give it 5 minutes on that. I should probably charge.
Okay, who remembers how to find the a 2x2 determinant? It was just a little algorithm.
It's 3 times 1 minus 7 times -2.
Almost. You had it. It's not this minus this. It's the other way. It's this minus that. So it'll be 7 times -2 minus 1 times 3. Does that make sense? So it's kind of like if you imagine making this sort of a shape, starting that way, and then coming around, going that way. Start with the downward, and then come back, and these are the ones you subtract. So yeah, 7 and -2 is minus 1 and 3. That should make -14 minus 3. Is that okay? How about this next one?
Times -8.
6 minus -8. Yeah, that's good. And 2 negatives make a positive, so it's 6 plus 8, which is 14. Easy? Let's see. How about a 3x3?
Does he want like 19 million for 1 year? Oh, actually. That's so much. That would put so much stuff. Well, that's like 24, like 5.
Here's a 3x3 matrix. How do I do these?
You have to copy down the first two, like braces.
Good. Yeah, and then I'll do like faint lines, maybe like yellow. And I'll multiply those, and I will subtract the multiple of these. So we have 5, 2, and 1. We have 2, 1, and 0. -3 and 4 and 1. And this way I have 2 minus 3 and 2. That's minus 12. We have 4, 1, and 1. 0. So these ones are all positives, and these are all subtracted. So 10 minus 12 is -2, plus 12 is 10 again, minus 4. Wait, I lost where I was. Minus 2 plus 12 is 10. Minus 4 should be 6. What kind of calculators do you guys have?
One with numbers on it?
Well, some of your calculators will do the determinants. What's that? I don't know about that one.
This one?
Mine's
Yeah.
older, Blue.
Yeah, if you got one of these chunky graphing ones, it'll do it.
This one's good.
And if you've got the ones that, mine's broken, but if you got one that looks like this, the TI-36X Pro, these will also take
I have a
determinants.
TI-83 Plus.
Yeah, that's
I have a
good.
TI-84.
So I'll post some
They're a
videos.
little better than me.
I do like if you guys know how to do these by hand, but
I do not.
it is not necessary, actually. More important that you know that they exist, that you can use them to do certain things. I'm going to show you guys a couple videos here. TI-84 determinant matrix. Let me put some audio through the TV. Are you guys ready to watch how your calculator can do some things for you?
Let's go to matrix and scroll. So we have to make one. So let's go to matrix and
So notice he hits second, and then the inverse button has matrix above it.
No, mine
Mine doesn't have.
Yeah, only pretty much the TI-83 or 84, Ryan,
You need that stuff with the guys?
or one of these. No, you can do it by hand, but I'm just showing you that some calculators can do it. So you go into the matrix menu and you go over, you press right to go to the edit menu, and you can choose one of your matrices.
let's make matrix G. Let's make it a 3 by 3.
So he just typed, it gave you dimensions, but you can type, you can overwrite that. You can type 3 and then make that a 3. And when you press enter, it'll create a 3 by 3 matrix.
Watch this.
And then you can just move around in your matrix and fill in what it should be.
So basically, you're saying that part 2 of this test got a whole lot of
Too quickly.
Yeah, if you have the calculator. I think it's good to
Quick after you've entered all the elements.
be able to do it by hand should you be in a pinch, but the bigger they are, the more human error there's possible. So it does not hurt to do it this way.
Now, go to matrix.
Now, then once you put in your matrix, you sort of quit out of that. And then you can go back into your matrix menu, go to the math,
Narrow determinant.
and the determinant is this function, DET.
Center.
And then it wants to know which matrix you want the determinant of. So you're going to go back into your matrix menu.
And then more. So again, go to matrix menu.
And this time you go in the names to find it instead of edit.
Like the determinant of matrix G is 0.
And there you go. Alternatively, you could always do something like let's see what this looks like.
Okay, so okay, for our test, is this gonna be like for these 2 sections, then there's gonna be a second part to these 2?
No,
Or is it gonna be one test for all these?
it's not exactly split that way. It's but it's 2 tests. So it's going to be solving equations 1.
Or 2?
Well, let's go through them again. I'm going to type this out also in the classroom, but it will be all of solving equations 1, That'll be on the first part. Solving equations 2 has a lot of line-based stuff, like find the slope or find a line going through this point. So that'll be on the second part. You have to go down to question 14, and then you will get, those questions will also be on part 1. So 14 down. And then I think in linear relationships 1, when they ask you to solve, actually no, it's in linear relationships 2. When they ask you to solve the system, when they give you 2 equations and ask you to solve the system, those questions will be on the first part too. They're kind of related because your system of equations are linear equations, so they're both linear. But I'm concentrating more on the graphs later and the slopes and stuff like that. And I'm concentrating more on solving systems in the first test.
Is it gonna be like a super long test or like 10 questions?
No, it won't be super long. You'll be able to do it.
Or 10 questions?
I like to make duplicates of, like, I like to ask the same type of question more than once. Yeah, probably. I'll try to make it so that it's doable within an hour. And if you really know what you're doing, it probably would take half an hour. I like people to wrap it up before the end of the class. And I know some people take longer than others, so.
He's a dark horse.
All right, so any questions for me? Anybody for this test? All right, are you good, Abby? Okay, then I'm going to let you go, and then when Google processes this video, I will post this along with the video that I made yesterday. So you should see at least 2 more videos go up on that playlist. You have a good rest of your day.
I don't know, I run over it.
All right, bye.
My nose.